Okay, so this is for second grade. We're going to learn about two different methods to solve problems. The first problem states, there are 10 students in kindergarten. 3 are boys. How many girls are there in kindergarten? So we know the problem tells us that there are 3 boys, right? And we also know that there are 10 children. So that means we have a whole. The 10 represents the children all together, and then the 3 represents a part, which that part is the boys. So on a part-whole diagram, the small part represents 3, the boys. This whole part, we know, represents 10, all the children together. Now we just need to find the missing part, right? There is a missing part, so we'll put the question mark there. So when there's a missing part and we have a whole and at least one part, we know that the problem is a part-whole. So to represent this with strip diagrams, we can see that the whole would be this whole strip, and then the part is this green, the small green part, which represents 3. And now we also have another strip that we do not know what it equals yet. So, to find the missing number of girls, we must look at how much of the whole part is not filled from the boys. That would be this. To find the missing part, we can use equations, right? There's a few equations here that we can use. And these equations can be, we can have the 10 children all together minus the boys to find the missing part. And 10 minus 3 would equal 7. That is one equation. The next equation would be something like this. 3 plus the missing part equals 10. Well, we found out that 10 minus 3 equals 7, so if we include 7 in the missing section, 7 plus 3 would equal 10. We found out that 7 children in the classroom are girls. Okay? That is how you use a part-whole diagram and method. Now, for the second problem, it states, Sydney had a collection of 35 baseball cards. Cody gave her more. Now Sydney has 120 baseball cards. How many cards did Cody give her? Well, we know that Sydney starts out with a number. So she starts out with a number. That goes right here. That's 35. And we know that she ended up with 120. The 35 represents what she started with, and the 120 represents what her result was at the end. Now, this part would be called the change because it is what Cody gave her that made her have 120 cards all together at the end. So therefore, we have a start, a change, number of cards Cody gave her, which we do not know yet how many he gave her. And the result is 120. So this problem is a join problem. It deals with only Cindy's cards and it is not comparing anyone else. So for strip diagrams, this is the whole 120. If there is 35 cards she started with, we need to find the missing part, which would be this green strip. And now to find out how many cards Cody gave her, we can use another equation. The equation can look like this. 120 minus 35 equals the change. That would equal 120 minus 35 would equal 85. So the change is now 85 cards that Cody gave her. You could also represent it like this. 35 plus 85 equals 120. And that is how we can check to make sure that our change is correct. It is a join problem because we were only thinking about Cindy and not comparing the number of cards that maybe Cody would have. So that is how you use two different types of methods to solve problems.